Hi guys, and welcome to Node Unit Testing in Depth. My name is Murtez and I'll be your instructor for the course. Unit testing is one of the most important parts of programming. If you have a piece of code, you should have a unit test to go with it. So in this course, we'll be going through everything from the most basic functions to testing callbacks, testing promises in 4 or 5 different ways. We're going to look at test doubles, so spies, stubs, and we are going to test routes, as well as some of the less common items you see around. We're going to test ES6 classes, as well as private code, which a lot of people don't seem to pay attention to, but is very important. By the end of this course, you should have a really good grasp of unit testing and be better than most average developers. One of the points of this course is to teach you how to think about unit testing and not simply how to call a function in an assertion library or how to do the actual test itself. We're going to look at a lot of code. We're going to test it in different ways to give you different options. Some things work in certain situations, others don't. And unfortunately, unit testing is one of the last things to be done and one of the first things to get dropped on a project due to time constraints or simply because it is a bit tedious. Unit testing is the broccoli of programming. We're going to be eating broccoli for the next 3 hours or so. Now, if you like broccoli, that's great. I don't. I never eat it in real life, but I do unit test because I have to. And wherever you work, they're going to require you to do it. If they don't, then you should be looking for another job. So without further ado, let's begin unit testing. This course is for people who know the basics of Node. You don't need to be an expert by any means, but you should know what Node is, how it works, the basics of modules, and how to create functions or a simple project. If you do, you will be fine. If not, I suggest doing some tutorials or watching some videos about Node and then coming and watching this course. Everyone has their own way of studying. So this may not work for you. Feel free to use your own method, but what I found helps is that, or my suggestion is that first watch the course at an increased speed, maybe 1 1/4 or even 1 1/2. Just watch the entire thing. Don't take notes. Don't try to follow along. Even if you don't understand something, just keep on going. And then when you're done that, go back, watch it again normally, and follow along. And by the end of the course, if you can try the exercises before I do them, that would be even better, so you can see your solution and my solution. It's very possible that they will be different. That doesn't mean you're wrong. There is more than one way to test a program, but it's really good practice. In order to start unit testing, you need a testing framework. And the most popular by far is Mocha. Chances are you're going to see it in every company, every project. If you go to Google and search for Mocha or go to their website, which is mocha.js.org, you can take a look at some of the documentation. It's well backed and fairly well done framework. So that's the first item we're going to use. The next item we need is an assertion library. And Node comes with a built-in assertion library, but it's very basic. You can use it for very simple projects, but to be honest, it doesn't have enough power to test a real application. If you go to Google and search for node assert, it will be the first option. And feel free to take a look at the documentation. If this is something you like, you can use it. It's there. You don't have to do anything extra. But as I said, it really is awkward to work with and doesn't have enough options to make a good assertion library. I'm going to create a new project using the default settings just to show you the basic structure. Then I'm going to install Mocha with npm install mocha -g, which makes it a global item since this is going to be used on my system for everything. I'll install it globally. I'm going to create a directory called test, and I'll make a new file in this directory. Call it test.js for now. The first thing you need is a describe block, and this is where all your tests go. It takes two parameters, first one being a string, and generally this is going to be the file name you are testing. So if it's a foo.js, I'm going to put foo.js here. The second parameter is a function, and we can put everything else here. Inside the describe block, I'm going to create a context, and context is just an alias for describe, but you can use it to distinguish. Now, by convention, this is going to be the function to be tested. So if I have a method called foo, I would put foo in here. And again, the second parameter is a function. And inside here, we're going to write our tests. And the tests go inside of it blocks. I know it sounds weird, but basically you say it, and then it takes a string parameter and then another function. And you would phrase this like you would say a sentence. So if a function is supposed to save a user, I'm going to say it should save the user. It should delete a file. It should add two numbers, and so forth. And for each test, you will have an it block. So you'll have one describe for the whole file, a context for each function, and an it for each single test. So let's begin doing some demos here. First, I'm going to include the default assert. Let's say const assert equals require assert. Then I'm going to say assert dot equal 1 and 2. I'm going to go back to my terminal, see my directory. Then you run the test with Mocha, then the file name. So we have a failing test because 1 doesn't equal 2, obviously. Let's go back and change this to 1. Rerun our test. Now it's passing. Let's create another test. So it should do something else. Assert deep equal, let's say name Joe to name Steve. Let's save this. Run the test again. Now it shows you that these objects don't match, and down here it'll show you what it's expected and what the actual value is. So you could look at the error and fix it. I'm going to change this back and rerun my test. Now we have 2 passing tests. Next, we're going to look at a pending test, and basically that means a test that has nothing. So I'm going to say this is a pending test. Let's go back and rerun. Now you see the third one doesn't have a check mark beside it, the third item, and it's in a different color. And at the bottom, it actually says 2 passing, 1 pending. So sometimes it helps to create a test for a function that you're not ready to test, or that may not exist yet. And this is a reminder for you to go back and finish this in the future. And this is the very basic structure of how you use Mocha. We'll get into a lot more detail through the rest of this course. In this video, we're going to look at before and after, as well as before each and after each. And these are functions you can run, and you can have them go before you start the test and afterwards, or before each test and afterwards. And these help us do setup, teardown, as well as a lot of other neat things like creating instances and stubs that we will get into. So let's take a look on how these are made in the code. I'm going to create it here, and it'll just say before, and this takes a function as a argument, and I'm just going to put a console log. I'll create an after section. Again, it takes a function. Let's put a console log. And let's run the test, see what happens. As you can see, we have this before and after, and the entire test of the context in between, which is great. So let's take a look at the before each now and see how that's done. It's very similar. So I'm going to go before each, and it takes a function. Let's console log it. And after each, console log that. Let's run the test. And as you can see there, now we have a before each and after each for every single test. Note that the pending test didn't actually run because there is nothing there, and Mocha knows it, so it just leaves it. But this is where we're going to create all our stubs, variables, and other codes that is used in each test that we don't really want to repeat. And we'll get into a lot more examples. This is one of the most important things actually in Mocha, so we will be using it extensively. In Mocha, you can have multiple contexts, and this will help you break things down. You'll have subheadings, and you can put before and after each for each section that you are actually working on. And the section is usually a function you're testing, so you have a different context for each separate function. Let's take a look at it. It's the exact same. Just create a context, and I'm gonna make a pending test. And let's run them to see how it looks like. Now, as you can see, this another function, this is our subheading, and we have the test under it. Notice that it didn't run the before and after because this was for the first context. Let me just clean this up a little bit too, so we can see it better. I'm gonna comment these out, rerun the test. So you have your subheadings, you have the tests, and now when something fails, you know exactly where this function is because you could have technically multiple tests that say checks parameters or something. And it's just a really fine way of breaking things down and keeping everything separate. Another tool we need is an assertion library. The built-in one can do some things, but it's very limited. So we're going to look at Chai, which is the most popular one by far. If you go to chai.js.com, that's their website, you can take a look at it. It has 3 styles: should, expect, and assert. They all do the same thing. It just depends on your preference. Although I have noticed that should is a bit more hard to work with. So in the course, we're going to use expect. It's very natural and easy to use. The other thing about Chai is that it's very extensible. It has a lot of plugins that do pretty much anything you need. And during the course, we're going to take a look at a few of those and show you how to use them with the library and generally make your life easier. So let's begin. I'm going to install Chai with npm install, save it as a dev dependency. Let's give it a second here. Okay. Next, I'm going to create a new file. Let's say chai test. I'll include it. And I'm going to say const expect equals chai.expect. And this is how you assign the style you want to use. In this case, we want expect, so chai.expect. Next, I will create a describe block like our original tests. I'll create a test for it. So it should compare some values and expect 1 to equal 1. Let's and this is how basically you do your check. It kind of flows like a sentence. So expect this to be so and so, or expect this to equal some number. And you run it with, first of all, let's go there, and you run the test with mocha chai test. The test passes like normal. I'm going to change this to 2, and now it gives me an error, expected 1 to equal 2. I'm going to say it should test some other stuff and expect, let's say, this object here, name foo, to equal name foo. Now this isn't going to work, so let's see. Let's go switch and run. So we got this error. Even though the objects are the same, I mean, it's clearly name, foo on both. But because objects are pointers, that's not going to work. So we have to use something called deep equal. So I'm going to say expect to deep equal foo. And this will compare basically the properties. Run the test again, and it works now. So this is something to keep in mind. Let's try some other stuff. Let's say to have property name and to equal foo. You can change these, chain these calls. Expect 5 bigger than 8 to be false. Expect this to be an object, even if it's empty. This is how you check the type. Expect foo to be a string. Expect 3 to be a number. You can also do something like expect, well, bar to be a string, obviously, with length of 3. So again, chaining. Expect some array dot length to equal 3. So you can do it both ways, just whatever style you prefer. I'm going to say expect null to be null. Now, when you're checking for a null object, you can't say equal. You have to do this. You have to say, expect whatever my result to be null. Otherwise, it won't work. Expect undefined to not exist. So this is another one. And expect, for example, some object to exist. This is how you would check if you were getting a result. And one of the checks you want to know that it's there. For example, if you're checking a timestamp that you don't know what the value is going to be, you can say expect my object to have a timestamp, and just leave it at that sort of thing. We'll get into more examples as we go through this. Let's run this just to make sure everything works. And all the tests are passing, so we have no problems. In this video, we're going to look at how to structure your application. And by convention, there's 2 ways to do it. So I made a few changes to the test file here. The first, look, I put all my my JavaScript files in this library folder under v1, because you're commonly going to run into that. You have different folders, different versions. And the first way of structuring this is to have a test folder in the root, and this is probably the most used way of doing it. You can have, like, you'll have a test folder in the root, and you will mirror your application structure in that test folder. So if I have a lib/v1/foo.js and I want to test that, inside my test folder, I will create a lib/v1/foo. And you have to do that for every single file in your application. The other way, which is less common, but I personally think it's more intuitive, because I've ran into issues when you try to move something or add a new version or like shift some files around. You have to remember to go back and change it in the other directory. And God forbid you're actually moving an entire thing over, so you'll have to go to every file and change it if you change the paths, if you haven't done them right. The second approach is having the test file inside each directory with the file you're trying to test, but adding something like .test.js to the end of it. So if I have a foo.js, I'll have a foo.test.js. And when I'm running my test, I can have it look for anything with this pattern and only run that. The reason I like this approach is because if I am updating a file, the test for it is right there beside it. Also, if you're doing a global search with the original one, you'll see like foo.js twice, for example, if you have a function name in both. And you have to actually take a look at the folder path to know where that's, if this is the test file or the original. So again, you can feel free to use whatever you like. The test structure one is probably the most common, but for this course, we're going to use we're going to put the files in the same folder just to keep everything in the same place. In these files here that you see, I just put some console logs in the in the bar and the foo files. So those ones shouldn't test. And I'll show you why I did this. This can cause a bit of a problem. If you take a look at all of these, they're all the same thing. They just, this bar file is the file we were working with in the previous videos. I just renamed it. The foo file also just has a console log. The foo.test.js is the second file we were working on with to show chai. And here I have this nested file that has a console log in the nested.js and just a pending test under nested.test.js. So let's go to the command line and see how you would run this. First, let's type mocha and then give it the directory with the recursive flag, so it will loop through all of them. This is the common case. So it looped through. We have the nested folder. We have 7 tests in total. Yeah, so 4 and 3 pending. And as you can see, everything is running. This env undefined is just an environment variable. We're going to talk about it in a bit. I put it in one of the folders. Now let's try the other one. So if I did mocha/lib with the recursive flag, let's run that. You see those console logs. So this shouldn't run, and that's because it will look for any JS file, and those are JS files. Let's try adding the pattern. So you'll often see this /*/star.test.js, and this means look for anything that has .test.js at the end and only run that. But now we only have 6 tests. It didn't actually loop through everything through the nested files. And this is finicky. Sometimes it happens, sometimes it's not. One of the ways you can fix it is by putting the path in quotes, basically. So I'm going to just put single quotes around this thing, rerun the file or the test. Now we have 7 tests. Again, depending on your distribution, this should work for most systems, but depending on your distribution, you may have to tweak this a little bit. And if you do a search on Google, you'll find people with the same issue. If you go to package.json, you'll see there is this test file. In here it's empty, but sometimes you may see some weird string in there by default. We're going to put the mocha command here. So I'm going to say mocha single bracket .lib, and then I'm going to put my pattern. Save the file. If you go to your terminal, now you can type npm test. And I appear to have missed a slash. So this should be here. Okay, let's rerun that. Now you see the tests are running. We have 7, only the files we want to run. And this way, you don't have to keep typing the mocha command and pointing it to a directory. And you can have different tests. So I can have a test that does, for example, my unit testing. I can have another test that does integration testing or some other type of test. Or if you want to test a single, you want to run a test with a certain environmental variable and another one with different flags, this will save you from having to keep retyping your code, and just run the simple command and you're good to go. And you can add multiple one of these. So I can have test, I can have test2, I can have whatever you like. You can call the command any name you want, and you can just put the corresponding command to it. For this course, we are just going to use this basic test to go through our files and folders. In this video, we're going to look at environmental variables and something called cross-env, which is a node module that we'll use. Now, if you don't know what environmental variables are, basically, when you run Node, you can set an environmental variable that tells you For example, if this is a development mode, if this is a production mode, these are the most two common, development and production. And in your code, based on what environmental variable you have, you would, for example, set your connections, set the URL for what server you want to use, set a demo account, for example, with a third-party API that you're trying to test, and so forth. They're really essential. So if you don't know what they are, I suggest looking for them. If you go to Google and search for cross env, this basically helps standardize the environmental variable across, so we don't have to go through hoops when we are trying to set it in our package.json. You can, if you scroll down, you can install it with this command, and there is a warning that says, make sure you use this and not mistype it. There are some malicious stuff on npm, unfortunately, once in a while. So I'm going to copy that, run the command here, and sometimes it takes a little bit to install, unfortunately. If you go back here, I'm going to put cross env and then node_env capital equals develop and then a space. Save the file. Now in my test file here, in my bar.test.js, I have a console log and I'm printing process.env.node.env. That's where the environmental variables will live. So let's run this test and see what happens. I'm going to do npm test. And as you can see on the third line here in the test, env development. And this is what we set in our package.json. So let's go back here and let's do a check with this and then do a condition, an if statement. So I'm going to say if process.env.node.env equals development, then do something. So I'm going to put a console log here saying this is development mode. And normally this is where I would set my variables or whatever else I want to change that to only run under development mode. Now if I run the test, this console log comes through because it is the correct mode. Normally you'd have the default mode in your application as develop if there's nothing else set, or sometimes people write their applications to only run if there is an env and it's either production or develop, otherwise throws an error. So whatever your company generally uses, that's what you would do. I can't stress how important environmental variables are. You never want to run your tests in a production mode by accident, because things could go like really, really badly, especially because a lot of times in tests you would drop your existing database and create a new one. So pay attention to this. This is very important. Okay. Right? In this video, we're going to take a look at testing the add function. It's a standard function that has two arguments. It will add them and return the total. So very basic here. In my demo.test.js, first I will include chai, and then I will use chai.expect. Next, I'll include the demo.js file, and my describe block will say demo. The context will be the add function, and here it should add two numbers. And expect demo.add 1 and 2 to equal 3. Now in my terminal, I will run it, and we have one passing test. So I will change the expect just to make sure this test is actually working to 4, and now it fails. So expected 3 to equal 4. In this video, we're going to look at testing an example of a callback function. In my demo.js, I have an add callback, and it does the exact same thing as the add function we tested, but it adds a half-second delay to simulate some kind of a process, and then returns the answer in the standard node.js convention of error first and then the result. So first I'll add a context, so callback add, and here it'll say it should test the callback, for lack of a better name. Now here we have to add a callback function to let Mocha know when a test is completed, otherwise it will time out. And the first thing I'll do is call demo.addCallback, pass in some parameters, and then a regular callback function. And in here, the first item I'll check is the error to make sure that it doesn't exist. So I'll say expect error to not exist. If there is an error of any kind, the test will fail and we will know. The next thing is just checking the result. So expect result to equal 3. Now let's see what happens if I run this as is. My test timed out. So let's go back and add done at the end. I'm just going to change this from the first test so that we don't keep getting errors. And there you have it, 2 passing tests. In the next section, we're going to look at testing callbacks and promises. And it's scary how similar Node is to real life. Like when a woman promises to call you back and then she doesn't, and you throw an exception. But I digress. In this video, we're going to test the add promise function, which takes 2 parameters and then unnecessarily resolve them using a promise. But we're using that to illustrate a point. I'm going to create a context and say test promise. Next, I'm going to create the test, so I'll say it should add with a promise. And this needs a callback. So I'm going to say demo.addPromise, passing 2 numbers, .then. And then here, I will do my expect, so expect result to equal 3. And then have to call done. Let's run the test. So this is working now. Now I'm going to add a catch clause to catch any errors and call done in here in case there's anything. And I'm gonna put a console log just to show us that there was an error. Now I'm going to throw an error here, or return a rejection, just to simulate one. I'll comment this, run the test, and let's see. Oh yes, I should be passing the exception to done, not done to itself, and risk destroying the universe. Rerun the test. So now we have a failing test. And the reason you're seeing this invoked with non-error, Mocha doesn't like it when you try to pass a string. So it says you should be basically passing instance of error, which is not a bad idea generally, just so you have a regular structure with a message and a stack trace in case you ever need it. So I'm going to change this here, rerun my test. Now we have an error that says fake, which is what we rejected with, so we know the test is working and the failure case is working as well. I'm going to put everything back and rerun the tests just to make sure everything is clear. And in the next test, we're going to return a promise. You can test it this way. So it should test a promise with a return. I'll do return demo.add promise 1 and 2, and then .then, and I can do my expect here. Expect result to equal 3. Let's run the test, and it passes. I'm going to comment this out and then try my error again. There you go. The next way of testing promises is using async await. If you don't know what that is, it basically lets you run your test from top to bottom, because a lot of times you can't really move on without getting an answer. So I can say var result equals await promise add, and then continue with the next steps. Let's begin by creating a test. I'll say it should test promise with async await. Let result equals await, and then the promise name, so demo.add promise, and this should say async up here. Now I can do my check, expect result to equal 3. Let's run the test. Everything passes. Let's go back and change it just to make sure that this will fail. Okay, that's good. I'm gonna comment these and uncomment my fake rejection to make sure that works. And we have one rejection. Now I'll put this back. The last way of testing promises is using a plugin called Chai as promised. If you go to the Chai website under plugins, it's listed right there, Chai as promised, and it lets you do things like expect my promise to eventually equal or eventually be resolved or rejected. Let's install. I'm going to require it. And you have to use it afterwards. So chai.use, and then the variable name, so chai as promised. Now this uses async await as well, so it should test promise with chai as promised. Say async, and I can do it on one line, so await expect demo.add promise to eventually equal 3. Let's run the test, and it works. So let's fail it. One error. And the good thing about this is that you can test multiple conditions in the same block. So let's say I have a promise that only accepts certain types of input or a range of numbers. I can do 5 lines that say await expect my promise to eventually equals this with so and so parameter, as opposed to doing a return where you'll have to have one test for each block. So this really cleans up your code. In this course, we're going to use a library called sign-on for test doubles. And what test doubles are, they're basically functions we can inject into our programs in the form of spies or stubs, and they will let us know what's happening inside behind the scenes. So we can take a look at a function, see what it's doing, or we can stub it completely, which is one of the main or the most important things, since isolating the code you're testing is the number one thing in unit testing. You can search for the website, it'll be the first result. I'm going to install it with npm install and save it as a dev dependency. In this video, we're going to test this foo function, and all it does, it has a console log and a console warn, but we want to make sure that when we call it, it actually does this log and warn with the corresponding messages. So let's go back to our code, And I'm going to include sign-on, since this is what provides us with the spies. And down here I'll create a new context. I'll say test doubles, and it should spy on log, since this is what we're spying on. So first we'll create the spy, sign-on.spy. Now the first parameter is the library or method I'm trying to spy on, in this case console. The second parameter is the actual function, so it will be log in our current case. That's what we're spying on. I'll call foo normally, and then I'm going to do expect spy.called once to be true, so that it was called one time. Now there is another way to do this. If you go to the chai.js plugin directory, something called sign-on chai, and it's a handy library that lets you do the same thing but in a different syntax. So if you go under plugins, select sign-on chai, it lets you do checks like expect spy to have been called once or called with. So same thing, just different syntax preference. I'm going to install it as a dev dependency. Just wait a second. Now back in our test, I'll do expect spy to have been called once. Next, I'm going to include it. So sign-on chai equals require sign-on chai, and then you have to use it as a plugin. So chai.use and then the plugin name. Now let's run our test. Now, as you can see, log and warn were both printed. Nothing changed, but our test passed, so they were called once each. Now, after you call spies, you have to do a spy.restore. And what that does, it resets the counts and everything, so that in your next test, if you're checking on called once, for example, your numbers match. Otherwise, you can have some weird behavior. So if the first test calls the spy and then you don't reset it, on your next check, those numbers will add up, and then you can, you have failing tests when you don't know why exactly. We'll get into a lot more detail on this once we get into stubs. One of the most important things is in unit testing is keeping your code isolated and only testing the function in question. If I have a function called add user and it takes a username and then saves it to the database and then prints out a welcome message, I want to check that my function attempted to save to the user database, but I don't want that to actually run. And you do that with a stub. You fake the call so your function thinks it went through and it can continue, and you only test the parts. So I check that it attempted the call, and then I check that it actually did the console log or whatever else it's supposed to. And we will get into a lot of stubs later on in the course to show as examples. They're one of the most useful things when it comes to unit testing, much more useful than spies. Spies are a lot more useful when you're doing other kind of testing where you don't want to stub the function, but you still want to keep an eye on it to see what's happening and what something was called with, what it did, and so forth. In this video, we're going to stub the console warn in our function so that it never gets called, but we're still checking to see that the program attempted to call it. I'm going to start by creating a new test here. I'll just say it should stub console warn. I'll create the stub, which is the exact same as the spy. First parameter is the module and then the function name. I'll call demo.foo and then do my expect. So expect stub to have been called once. So it's very similar to the original, but now let's run it and see what happens. Now, as you can see, console log was called, but there is no console warn under it. So it was stubbed properly, and we know it attempted to call it one time. Now, if I go back, and I'm going to have the stub call a completely different function. So you do that with calls fake. which accepts a normal function as parameter. I'm going to put a console log with a message from stub. So if you run the test again, you'll see message from stub down here. So not only did we stub the console warn, but we have it calling our own custom function. In this case, it's not really that useful, but let's say you have a function that calls to the database, but you don't want the call to actually run, so you have a stub that returns a fake object you can work with and move on. Now, stubs and spies are very similar, except for the stubbing part, so I'm going to use stubs as much as possible. I'm going to go back and change this message here, just to make sure it fails, and rerun my test. And there you go. So the stub fails because it was expecting a certain string but got a different one. This is useful when you're trying to, for example, if I'm checking for an object that has a name property, but it doesn't, it will fail. And we'll get into a lot more example once we start testing the applications with stubs. It's probably one of the most things you will use when you're doing unit testing. In this video, we're going to test this export.bar function. It takes a file name. First, it calls this exports.createFile, which is just a fake function that returns a resolve after 100 milliseconds. But then it calls this private callDB. Now, the first function we can stub with sign on, but the second one, we're going to have to use a library called rewire that allows us to interact with private functions and variables. If you go to Google and do a search for node rewire, this will be the first result. If you go there and scroll down, rewire works by adding this __ set and get variables to our modules, and we can use them to get a private function or set a private function. So first I'm going to install it and save it as a dev dependency. Next, I'm going to include it here. Next, you have to call a library with rewire instead of require. So you just change it to rewire. And down here, I'm going to create, I'm going to add stub restore for our last test because we forgot to add it. Next, I'll create a context. I'll say stub private function. And it should stub create file. First, I'll create a stub first argument is going to be demo. Next, create file method, and I'm just going to say it resolves. So it will resolve with this value, this stub. Next, I'll create an empty stub, and you can do that and then assign it later. So I'll just say sign on.stub with no parameters, and this one will also resolve with the call db_stub value as a string. Next, I'll call demo.set. The first argument is going to be the name of the function I'm trying to replace. So in this case, call db. The second argument is what I'm trying to replace it with. So this will go through demo, look for call db, and change it with my stub. But this could be anything. It could be a function, a class, whatever you like. Next, I will call this with await. So await demo.bar, and I'll pass in a fake file name. Now I can do my checks. Expect result to equal call db stub, because this is what our function returns, the result from call db. Next, I'll do expect create stub to have been called once, so we know it attempted to call it. And I will do the same thing for my second stub. Expect call stub to have been called once. And I'll add one more thing here. I'm going to copy this, and I'm going to say called with test.txt. So this means it was called with this parameter. Run my test, and I have a error, and this just means that this should be an async function. My tests run and the function was stubbed properly, and we're gonna go into a lot more detailed examples of this once we start testing the actual application, but I just wanted to show you that it does exist and this is something we can do. Cool. Thanks for watching the video, guys. If you learn what was shown, then you have all the knowledge you need to start doing unit testing. The only thing left would be to go out there and actually practice. That being said, if you'd like to see more examples, then please do check out my Udemy course. This was the first part of it. The second part is going through a lot of code and just applying all these methods together and showing you how to test real life situations that you will run into from my experience. So do check it out. It would also help me keep making these videos. So again, thanks for watching, and I hope to see you on the other side.